In this video, we will learn about the basic rules of differentiation and apply them. Let's start off with the idea of differentiation. If I draw a tangent at a particular point, what is a tangent line? A tangent line is a line that touches a particular curve at only one point. So this is a little bit exaggerated for simplification purposes. At this point, the slope, the gradient of this line can be calculated using the concept of coordinate geometry. Take 2 points on this line, apply the formula gradient equals to change in y over change in x, and then you will get the answer. But the answer will vary from person to person. Somebody might be drawing a tangent a little bit skewed like this. So the answer will be an estimate rather than accurate. So this answer will actually be an estimate. But if we want the exact answer, we get this exact answer from the rules of differentiation. And I'll also use the term derivation, which is an old name for differentiation. So what we do is that we can get the differentiation, and that gives us the basic idea of gradient of a tangent. So dy by dx is defined as gradient of tangent to a curve, and at a particular point we can plug in the value and we can get the answer. Dy by dx, what does it mean? It means rate of change of y with respect to x. So WRT is the official symbol that we will use with respect to. So rate of change of y with respect to x, this is known as dy by dx. And what is it equal to? Gradient of tangent to the curve. Let's go to the very first rule. The very first rule says y is equals to x raised to power of n, where n could be any power. It doesn't make a difference whether it's an integer or it's a fraction, or it's something in decimal, or it could be positive or it could be negative. So n could be any power. When we differentiate dy by dx, what happens is that this power comes down, x remains as it is, and the power reduces by 1. That is the rule for differentiation. Second rule, y is equals to a multiplying with x raised to power of n, where this a is a constant. If a constant is multiplying, it doesn't make a difference. Dy by dx is a remains as it is, and the differentiation of x raised to power of n is just written at the top. So therefore, this will be n and then x and then n minus 1. Now let's do some examples based upon this rule. So we have y equals to x cube. Dy by dx is equals to 3 comes down, x remains as it is, power reduces by 1, which becomes 3x square. Y is equals to x raised to power of 10. Dy by dx, 10 comes down, x remains as it is, power reduces by 1, that is 10x power 9. Y is equals to 1 over x square. Write it in the proper format with a negative power, or it's the same thing as y is equals to x raised to power of minus 2. Therefore, dy by dx, minus 2 comes down, x remains as it is, power reduces by 1, that is negative 2, x raised to power of negative 3, and now we can write in the proper format negative 2 over x cube. Many more examples to be done. Something like y is equals to 1 over x, or x raised to power of minus 1. dy by dx minus 1 comes down, x remains as it is, power reduces by 1. That is minus 1 x minus 2, that is minus 1 over x square. Similarly, if we talk about fractional powers, y is equals to square root of x. Y equals to x raised to power of half. Dy by dx, half comes down, x remains as it is, power reduces by 1. That is half x raised to power of minus half. That is half into 1 over x raised to power of half, which can also be written as half into 1 over root x, which can even be written as 1 over 2 root x. Let's move to some more examples. Something like y is equals to 5x. 5x means the power of x is 1. Therefore, when we differentiate dy by dx, 5 remains as it is, 1 comes down, x, the power reduces to 0. So 5 into 1 into x raised to power of 0. We know that any variable raised to power of 0 is simply 1. So the answer comes out to be 5. Therefore, we can make a generalized rule. Y is equals to ax, dy by dx is simply a. So now let's do something similar. What if I have y is equals to simply a constant? The variable is missing because the power of variable is 0. A raised to power of 0 is 1. We know this from the rules of indices or exponents. So now when we differentiate it, dy by dx, that is 3 remains as it is, 0 comes down, the power of x reduces by 1, but because of the 0, everything becomes 0. So in short, we can say whenever y is equals to a constant, dy by dx equals to 0. Now let me write all the rules in one place. So I'll make a box and I'll write all the rules over here. The first rule that we wrote, that is y is equals to x raised to power of n dy by dx, that is nx n minus 1. Second rule, dy by dx is a constant multiplying with a variable raised to a power. Dy by dx is equals to a remains as it is, nx n minus 1. Third rule, y is equals to ax, therefore dy by dx is simply a. And the fourth rule is y is equals to c, therefore dy by dx equals to 0. So the original rule is this. This is an application in which a constant is being multiplied with a variable. This is an application in which the power of x is 1. This is another application of the same rule in which there is simply a constant because the power of x is 0. Now let's try out some examples in which all the rules are being applicable. Something like y is equals to x cube plus x square plus x plus 1. Therefore, dy by dx, differentiate each term separately. So we have x cube becoming 3x3 minus 1, x square becoming 2x2 minus 1. Derivative of x is simply the coefficient, which is 1. Derivative of a constant is 0. Simplify it out. This is 3x square plus 2x plus 1. That is the expression for this dy by dx. This is also known as the gradient function. Let's move on to another example. Something like y is equals to x multiplying with x square plus 2x plus 3. So first multiply out the x on the outside with each term, which makes it x cube plus 2x square plus 3x. This is still the expression for y. And now differentiate each term separately, dy by dx, that is 3x square, 2 as it is, 2x power 1, and the derivative of 3x is 3. So this simplifies to 3x square plus 4x plus 3. Some more examples. Something like y is equals to x power 4 plus x cube plus x square plus x plus 3 divided by x. So we have to divide it out. X power 4 over x power 3 over x power 2 over x over x plus 3 over x. Simplify it further. X cube, x square, x power 1, simply a constant 1, and this is 3x minus 1. It's all equal to y. Now differentiate dy by dx, that is 3x square plus 2x plus 1 plus 0 plus 3 minus 1 x minus 2. Because of the subtraction, this becomes 3x square plus 2x plus 1. Let's discard the 0, maybe at the very end, minus 3 over x square. That is the expression for the differentiation. What if some indices is more involved? Something like y is equals to square root of x and x square plus 3. Now we know that square root of x means x raised to power of half. We need rules of indices also. A power m into a power n, that is a m plus n. So first of all, write this thing as x power half. This is x power 2. This is 3. And now when we multiply, this is how it goes. This is x power half plus 2 plus 3x power half. We know that half plus 2 is 2.5, which is 5 over 2. So this is x power 5 over 2, and this is 3x power half. Now differentiate dy by dx. 5 over 2 comes down, x remains as it is, power reduces by 1. 3 as it is, half comes down, x remains as it is, half minus 1. Now let's simplify it further. So we have 5 over 2 as it is, x raised to power of 3 over 2. 3 over 2 as it is, x raised to power of negative half. Let's simplify it a bit more. So this is 5 over 2, x raised to power of 3 over 2. This is 3 over 2, 1 over x power half. And the last step of simplification, 5 over 2 as it is, x raised to power of 3 over 2. 3 over 2 as it is, 1 over root x. And that is the final answer for this particular step. So in this video, we have learned the basic rules of differentiation, and there are many more other rules to come.